Number 19, the acceleration of a particle moving only on the horizontal xy plane is given by vector A, which is equal to 3t in the I direction plus 4t in the j direction, where A is in meters per second squared and t is in seconds. At t equals to 0, the position vector r is equal to 20 meters in the I direction plus 40 meters in the j direction locates the particle, which then has the velocity vector v equals to 5 meters per second in the I direction plus 2 meters per second in the j direction. At t equals to 4 seconds, what are letter A its position vector unit vector notation and B the angle between its direction of travel and the positive direction of the x-axis. Okay, so the first thing that you have to notice in this problem is that the acceleration is not constant. So probably you're feeling that you should use this equation over here, x equals to xo plus vot plus at squared over 2. However, you cannot use this equation. So you cannot use this equation or a variant of the equation because the acceleration is not constant in this case. This works only for constant acceleration. So you cannot use this. So our strategy to find vector r, we will start from vector a, from acceleration, and then we are going to find vector velocity using this equation, and when we have the velocity, we are going to find the position vector using this equation over here. So we know that the acceleration is the derivative of the velocity in respect with time, and the velocity is the derivative of the position in respect of time. So let's first find our vector velocity. So we are going to use this equation over here. I'm going to send dt to the other side. So a dt is equal to dv. So we can integrate in both sides. And then we have to choose the limits of integration. So we are going to integrate from time going from 0 to t. And at times t equals to 0, the velocity is vo. We are calling this velocity vo to v. Okay, so those are the limits of integration. So the right side of the equation is really simple. So let's solve it first. So the integration of a from 0 to t dt is equal, so this integral is just v minus vo. Remember that we want to find vector v. So this vector is calculated at any t. So this works for any time, any value of t. So this is what we want. So let's isolate it. So vector v is equal to vo plus the integral from 0 to t of a dt. So v is equal to vo plus the, let's replace it first, the integral from 0 to t of vector a, which is 3t in the I direction plus 4t in the j direction dt. So we can integrate. So v is equal to vo plus, so let's do the integral over here. So it is equal to 3t squared over 2 in the I direction plus 4t squared over 2 in the j direction. And this integral is from 0 to t. So this 0, when you replace t from 0, this terms, the whole term goes away. So we just have to replace by t. So v is equal to vo, which is equal to 5 in the I direction plus 2 in the j direction plus 3 over 2 t squared in the I direction. So 4 over 2 is 2 plus 2t squared in the j direction. So our vector v is equal to 5 plus 1.5 t squared in the I direction plus 2t squared in the j direction. So we just found our vector v, the velocity, the velocity vector over here. So now we have to do the same thing, and then we will find the position vector. So v is equal to dr over dt. So v dt is equal to dr. So let's integrate this. We are going to integrate from rho, the initial position, to the final position, and t from 0 to t. And rho, I'm calling this vector over here. This is rho. So the right side of the equation is the same as what we have done over here. So the integral from 0 to t of v dt is equal to r minus rho. So r, which is the vector that we are looking for, is equal to r plus the integral of 0 to t v dt. So we have to replace this v by this value over here. I'm going to do that quicker than before, because I just showed how it's done over here. So replacing by the result of the integral, we would find 5t plus 1.5 t to the third over 3 in the I direction, plus 2t plus 2t to the third over 3 in the j direction. So if you replace rho, you're going to find, let's see, 20 plus 5t plus 0.5 t to the third in the I direction, plus 40 plus 2t plus 2 over 3 t to the third in the j direction. So this is our vector r over here. So now we have to replace, we have to find a vector r when t is equal to 4 seconds. So this is what we have to do for letter A. So this is just 20 plus 5 times 4 plus 0.5 times 4 to the third in the I direction, plus 40 plus 2 times 4 plus 2 over 3, 4 to the third in the j direction. And this gives us, let's see, 72 in the I direction, plus 90.7 roughly in the j direction. Don't forget to include the unit, which is meters. So this is the answer of letter A. For letter B, we want to find the angle between its direction of travel. The direction of travel is the same direction as the velocity. So we just have to find the direction of the velocity in respect to the x-axis. So first we have to find v when t is equal to 4 seconds. So using this equation over here, so we find that the velocity is equal to 29 in the I direction plus 34 in the j direction in meters per second, and the angle is just the tangent to the minus 1 of Vy over the y component over the x component. So this is the tangent to the minus 1 of 34 over 29, and this gives us 49.5 degrees, and this is the answer of letter B.